Hey, pre-calculus. Today we're going to be going over handout 15, and which is the angle sum formula. And so, angle sum formula, that's anytime we have the sum of two angles or difference, like so, or alpha and beta are two different angles, and we're going to be interested in both the cosine and the sine of these two characters. We want to know what is the cosine of alpha plus beta or minus beta, and also we want to know what is the sine of alpha plus beta and sine minus beta. So what these guys equal is what we are after. Okay, and so that's why we've constructed this semicircle right here to help us get to that point, because we want to think about angles and how they work in this case. So I want us to look at first this angle alpha. And note that this corresponds with point A for alpha. Okay, and then next, go ahead and take a look at right here, this angle beta. And note how this corresponds with our angle beta right there. Alright. So next, take a gander at this guy right here, our point alpha minus beta, and note how we get this point. We go all the way out to alpha, and then we come back a distance beta, because once again, note we return this direction here. We have an angle beta there. So how we got to P alpha minus beta is we rotated counterclockwise alpha, and then we rotated beta back. And that's how we get that point right there. And so this angle can be represented like so. Right, there it is. That is angle alpha minus beta. Alright, and that's how we get here. And so you can see that that's that angle right there. And notice the next thing that we're claiming. We have a single angle alpha minus a single alpha beta, right? So it's no longer the combined angles, now it's one minus the other. So looking at that, it seems like that should make sense, but we need to make sure we can see the picture to verify that this is the case. Alright, and let's make sure we use a different color here. So this is the angle alpha. So the first angle, alpha, you go all the way out to alpha. But now we're subtracting this beta, right? We're taking this part out of the equation. So now we get just that guy right there. And so the claim is what you see in green is the same that you see in purple. And you can kind of verify that that's the case for this way this is drawn. Everything seems to make sense. There's also an interactive demonstration on Desmos. You can access that with the QR point right there. If you have your phone, you can pull it out, or you can simply click on the link in Blackboard and you will get here. So note right now it's in roughly the same configuration as it was before. Right here is our angle, or our point alpha. Here is our point alpha minus beta, and this is our point beta. And so you can see that the claim that these angles are the same seems to be holding up, and you can also visually look at this and see how that is still the case regardless of which angle configuration we have. So I encourage you to kind of play with it and make sure that this angle and this angle is in fact the same for whatever angle alpha beta. Once again, you can access this at any time. So let's go on. So we see that this angle and this angle are in fact the same angle. And if those angles are the same, since we are dealing with a circle of a constant radius, which is what defines a circle, those chords will be the same. When I talk about a chord, I'm talking about the length of this line right there. That's one of our chords. And if you look at what we have up on Desmos, that is one of the things being displayed. And then we have this other chord right here. So again, since the radius of the arcs are the same, then one angle will have the same length of arc as another angle. Alright, so let's go ahead and fill this out, that these line segments have the same length. And so now we're going to apply the distance formula. Remember the distance formula, it's just kind of another expression of the Pythagorean theorem. And so for each line segment, and set them equal, right? We can set them equal to each other because of what we have going on up here. So we're going to apply the distance formula. Now remember, the distance formula is simply d squared equals the change in x squared plus the change in y squared. We want to set these lengths of these chords together. Now note that to find delta x and to find delta y, we need to have x and y coordinates. So let's go back to this picture and let's figure out what the x and y coordinates are. So one thing we notice is that this is in fact the unit circle, right? So the x and y coordinates will simply be the cosine and sine of the indicated angle. So right here, our coordinate is for x is cosine beta, and our coordinate for y is sine beta, right? And so down here, we're already given the point 1 and 0. And so for our x alpha, quite simply, that's going to be our x coordinate will be cosine alpha, and our y coordinate is sine alpha. And then for our point P, well, the x coordinate is simply going to be the cosine of alpha minus beta and the sine of alpha minus beta. Interesting, right? So recall cosine of alpha minus beta, well, that's one of the things that we're after here. It's one of the things we want to find out for our formula. Alright, so let's go down. And now that we've got our x and y coordinates established, let's go ahead and pick sides here. We have d1 equals d2. Let's stay consistent, and we'll keep this with the green side. That is this green angle here. And for d2, this will be what I am calling purple. Some of you guys might see a different color, but that's what I see, so that's what I'm going to call it. Alright, so what are the x and y coordinates that we're going to be working with? Right, because we want to apply the distance formula. So d1 is going to be the point from S to the point at P, and our d2, that will be the point from B to the point on A. Okay, and that'll help us keep everything straight, right? Alright, so now let's go ahead and write in the formula. And so we've got our delta x terms here, so that's we've got to look at the x coordinate for P first, and that's going to be cosine of alpha minus beta. And then minus the x coordinate for S, which you can see here is simply 1. So we stick that one there. And then plus the delta y. And so again, we look at the y coordinate at P, and that's sine alpha minus beta, minus the y coordinate of S, which is 0. Okay. Go ahead and press pause and try and find the distance for this guy right here, if you can, and then unpause it to see if you got it right. Alright, so right here, we're going to look at the change in x between B and A. So we look at what's going on at A, that's cosine alpha. And what's going on at B, well, that's simply cosine beta. Quantity squared. And then for delta y, we look at the y coordinate at B, which is, at A first, which is sine of alpha. And then minus sine of beta. I don't know why I put a plus right there, but there we go. Minus, there we are, squared. Okay, so we've got the whole thing set up. You can kind of go in and press the pause. If you don't quite see where everything goes, just refer to this picture up here. And after some introspection, it should begin to make sense. So I'm going to zoom in over here. I'm going to start doing our figuring. Notice I can square both sides right off the bat and get rid of the square roots. All right, so I'm going to go ahead and do that, and let's expand all these terms. So we've got cosine of alpha minus beta squared. Let's put the square right there. Minus 2 times cosine alpha minus beta plus 1. Okay. Now let's expand this term here. Be kind of easy since we've got a 0 hanging out there. So that's simply sine squared of alpha minus beta. So let's look at the right. Again, squaring both sides gets rid of this square root right here. So expanding this term, we have cosine squared alpha minus 2 cosine alpha cosine beta plus cosine squared beta. Right, that's just what happens when you expand this term. And now let's expand this guy. Plus sine beta squared. Okay, good. All right, let me go ahead and make a little more space for myself right here. All right, and we're going to go ahead and do some rearranging here in a way that'll make a few things make a little more sense. Let's go ahead and just move this to right here. And note what we have. That's cosine plus sine squared. What is that going to be? That's going to be 1. And now look over here. When we come over to the right hand side, we'll notice a lot of similar things happening with our rearranging. You can see right here we have a plus sine alpha squared. And so let's just look at that over here. We can see that we got a cosine squared plus sine squared going on right there. All right, so that is quite a bit of simplification. And then also see that this guy right here can go right over there, all right, because we can move things around because it's just addition. And lo and behold, this also is 1. So a lot of simplifications going on. And so when we combine everything, we have minus 2 cosine alpha, and then plus 2 equals, and then we got a 1 here and a 1 there, so that's going to be another 2, minus 2 cosine alpha cosine beta, minus 2 sine alpha sine beta. And note that we've got a 2 present in each and every single term, so that means they can all reduce to just 1. And so we can actually write this as negative cosine alpha minus beta right, just taking the 1 off of each and every one of these. And what's really cool, both have a 1 there. That's pretty simplified. And note, everything's got a negative sign, so we just multiply through by -1 to make everything positive. And we end up with this formula: cosine alpha minus beta equals cosine alpha cosine beta plus sine alpha sine beta. And that is the result we were looking for. All right, let's go ahead and highlight it with yellow gold here. There we go. Really make it stand out. All right, so cosine alpha minus beta, cosine alpha alpha times cosine beta plus sine alpha sine beta. That is what we are wanting to get. And so that's good. That's great. We got something for the difference of the angle. So this is what's called the angle difference formula. But we really want to know the angle sum as well. So what we're going to do is we're going to look at wherever we see beta, and we're going to replace it with negative beta. All right, so we're just going to write this down. Cosine alpha minus negative beta. It's going to make this a plus beta, right? We're just going along this formula here. Equals cosine alpha times cosine, and again we see a negative there, so we've got negative beta. And plus sine alpha times sine negative beta. Right, so negative beta showed up here, here, and right there. Note that's simply a plus because it was a minus right before it. Okay. And in case anyone's having trouble seeing it, why don't we just state it explicitly: minus negative beta. But we can make that a positive. Okay, and so we got cosine alpha plus beta over here. Plus sine pi over 2 sine theta. All right, so we're going to make a few quick observations. Cosine pi over 2, why, that's nothing but 0. And sine of pi over 2, that is 1. Right, we know these because we have them memorized from the unit circle. So cosine of pi over 2 minus theta equals sine theta. So that's pretty neat. That's a box-worthy result. we note that sine theta is simply a shift and a horizontal flip of the cosine function, right? Something that we've kind of already been noticing. The similarities between the graphs of cosine and sine only differs by a shift and a flip. All right, so we're going to go ahead and make a substitution to show something else here. We're going to let theta equals pi over 2 minus alpha. All right, so we're going to be plugging that into this equation right here. And so we're going to end up with cosine of pi over 2 minus pi over 2 minus alpha. Don't forget to put that in its own little mini parentheses there. And then on the right hand side we've simply got sine of pi over 2 minus alpha. All right, here's our substitutions here and there. All right, so note how these correlate to here. All right, so pi over 2 minus pi over 2, clearly 0. And then minus a negative alpha makes this cosine alpha, which is equal to sine of pi over 2 minus alpha. Alright, so note how this guy is parallel with that guy up there. And if we restate that with a theta instead, I'll write this up here. We'll do it in a different color so there we go. Sine of sine of pi over 2 minus alpha, theta I mean, equals cosine alpha. So when you see them, theta, I'm sorry. When you see them right next to each other, you can really see how parallel they are. Okay. So let's come down here and look at what we have. We want to look at the results of right there. Sine theta equals cosine pi over 2 minus theta. And we're going to make a substitution. We're going to substitute alpha plus beta in for our theta. All right. So we're going to have sine of alpha plus beta equals cosine pi over 2 of minus alpha minus beta, right? We just went ahead and distributed that negative. And since both of those were positive, they are both now negative. All right. And so let's go ahead and group these a somewhat different way. We're going to group these like so. All right. No change of meaning there. And now we're going to apply the angle difference formula. And so we have cosine of, let me go and highlight it so it's, right, that's the new one. And we'll call that one the old one there. There we go. So we have cosine of pi over 2 minus alpha times cosine of beta right, and so it's angle sum, so minus becomes a plus, and so now we have sine of alpha pi over 2 minus alpha and sine of alpha. Alright, so we're going to notice some startling results. cosine of pi over 2 minus alpha. Well, we already had that written down. That's the same thing as sine theta. Or should I say sine alpha? All right, interesting. And sine of pi over 2 minus alpha, well, we note that as the same thing as cosine alpha. So we can rewrite this whole thing as sine alpha cosine beta plus that should be a beta right there, plus cosine alpha sine beta. And there it is. That's our angle sum formula. Pretty neat, if you ask me. All right, and so let's put a box around this one. That one's awesome. A very important one to have under your hat. But we've got the angle sum. It would be nice if we had the angle difference. I think I got a little ahead of myself on that one since I was following the directions here, but that's quite all right. We'll just have extra space. So we simply replace, let's just come down here. We're going to replace negative beta, or replace beta with negative beta. And so let's go ahead and just fill it in right here. Sine of alpha, now it's minus beta, right? Angle difference, equals sine of alpha times cosine of negative beta plus cosine alpha times sine of negative beta. Okay. So we note right here, cosine of negative beta is simply the same thing as cosine beta, and sine of negative beta is the same as negative sine beta. So this is going to become sine alpha cosine beta minus cosine alpha sine beta. And that is the angle difference formula. All right, our box of gold there. Okay, so we're going to do a similar treatment where we summarize these two equations into one. So we have sine of alpha plus beta plus or minus beta equals, and so they both start off with sine alpha cosine beta. And note that when it's a plus, it's a plus over here, and when it's a minus here, it's a minus here. So simply plus or minus becomes plus or minus. Note we're not reversing the order of the plus or minus this time. And so they both end up with cosine alpha sine beta. And that is a very nice result. So combines both those two equations into one simple expression. All right, so let's go ahead and apply this to sine of pi over 2 minus theta. So note this becomes sine pi over 2 times cosine theta, and then minus cosine pi over 2 sine theta. All right, so what is sine of pi over 2? That's 1. And what is cosine of pi over 2? That's 0. So this whole thing becomes sine of pi over 2 minus theta equals cosine theta, right? So we went ahead and used the angle difference for sines to show this guy once again. All right. So one last thing, we're going to look at the tan of alpha plus beta. And so first off, we're going to look at this. We're going to go, okay, well, what is tan? Well, that's, rise over run, sine of alpha plus beta over cosine alpha plus beta. Pretty straightforward. And then we just make our substitutions. Sine of alpha plus beta is simply sine alpha cosine beta plus cosine alpha sine beta. And in the bottom we put the cosine, which we have down here, up here. Cosine alpha plus, we have cosine cosine minus sine sine. So let's come down here. And so we have cosine alpha, cosine beta, minus sine alpha, sine beta. Notice for both of those, the minus is always associated with the sine of the beta. All right. So first thing we're going to do is we're going to try and convert these sines and cosines into tangents. So on the top, let's look at, we got a sine alpha. Let's turn that sine alpha into a tan alpha. So we got to divide by cosine alpha to make that happen. What we do to the top, we must also do to the bottom. Alright, now we need to distribute those to both terms that we have here. And so sine alpha divided by cosine alpha, that's tan alpha. And we have a cosine beta. And the next one, cosine alpha divided by cosine alpha, well, that's simply 1. And so we're left with sine beta. So that's the top. Now the bottom, divide both sides by both terms, by cosine alpha. Cosine alpha over cosine alpha is 1, so we're simply left with cosine beta. And then minus, and once again we got another sine alpha, so that's going to make this tan alpha times sine beta. So next thing we notice, we've got a bunch of these sine betas hanging around. So we want to turn those into tans. So we multiply every term in the top by cosine beta, and every term in the bottom by cosine beta. And so first we look at this term, cosine beta divided by cosine beta is 1. So we simply have tan alpha. And then we come to this next term right there. Sine beta divided by cosine beta, well, that gets us tan beta. And so next we have cosine beta divided by cosine beta over 1 minus tan alpha tan beta. All right, so we got a nice formula for tangent of alpha plus beta, and this is strictly in terms of, sorry, I didn't mean to erase that, strictly in terms of tan alpha and tan beta. All right, so let's go ahead and look at this in the negative case, right? What if instead of summing, we're subtracting? Well, that means that, and keep in mind, tan is in fact a odd function. So anytime we have to use negative beta, like we do right here, that's going to turn the thing negative, right? Here tan alpha is still positive, unaffected, but we've got a beta here, so we've got a negative beta, which means that it will be plus down here, right? So it all ends up being tan of alpha plus or minus beta is tan of alpha plus or minus tan beta over 1 minus or plus tan alpha tan beta, right? So whatever you're doing up here will affect these two guys here, okay? All right, that is all I have for this handout. Until next time, have a good day.